Hello students, today I am here to teach you chapter 16 in your textbook, that's called Parallelograms 1, and chapter 17 is Parallelograms 2. So I'll combine both units together and teach you all theorems at once. Now we'll take what's a four-sided figure. What you call four-sided figure? A quadrilateral. So what's the definition of a quadrilateral? A closed plane figure bounded by four straight lines. So what's a quadrilateral? Closed plane figure bounded by four straight lines or straight line segments. So this is a quadrilateral. I'll take this one as A, B, C, D. Now we'll see what are opposite sides and opposite angles. Now when you take this quadrilateral, take AB side. AB side and CD sides are opposite sides. So we can write what are opposite sides. Opposite sides AB and CD. If you take AD, what's the opposite side of AD? Opposite to this is BC or CB. So those are opposite sides. Now we'll identify what are opposite angles. Now there are four angles, A angle, B, C angle and D angle. So if you take A angle, what's the opposite of that? Opposite to this is C angle. A and C angles are opposite angles. If you take B, what's the opposite angle of B? If you take B angle, the opposite angle is called D. B and D are opposite angles. So when you take a quadrilateral, that means four-sided figure, you need to identify what are opposite sides and what are opposite angles. Now we'll take these two shapes, rectangle and a square. Those are quadrilaterals, four-sided figure. So what is a rectangle? Rectangle is a shape like this. Angles are 90 degrees. I'll label this as A, B, C, D. In this rectangle, what are opposite sides? Opposite. So I can write pair of opposite side. Pair of opposite sides. That means 2. So if you take AB, what's the opposite side to that? You can label as CD. If you take AD, what's the opposite side? You get BC. And what are opposite angles? If you take A angle, what's the opposite of A angle? A and C are opposite angles. What's the other one? If you take B, B and D are opposite angles. What's a square? Square, you get all sides are equal. And these are 90-degree angles. I'll label this as L, M, N, O. So in this square, what are opposite sides? LM and ON are opposite sides. If you take OL, what's the opposite side of OL? MN. Then if you take angles, if you take opposite angles, L angle and N angle are opposite angles. O angle with M angle are opposite angles. So these are all quadrilaterals, four-sided figures. Now we'll look at what is a diagonal of a quadrilateral. So how many diagonals are there? So take any quadrilateral four-sided figure, A, B, C, D. So what are diagonals? When you connect A and C, opposite angles, you get AC line. And when you connect opposite angles B and D, you get BD line. So these are called diagonals. So I can write AC and BD are diagonals. So AC and BD are diagonals. So when you get a quadrilateral, make sure to identify what are diagonals. So here when you are taking two diagonals, so we can say these two diagonals intersects at point O. If I take this point as O, I can write AC and BD diagonals intersect at O. This is the O point, intersecting point. Now we'll look at another quadrilateral called parallelogram. So how can we draw a parallelogram? So parallelogram is a four-sided figure and pair of opposite sides are parallel. That's the definition of a parallelogram. So when you take a parallelogram, opposite sides are parallel. This line is parallel to this one and I can draw this one parallel to this one. So this is called a parallelogram. I'll take A, B, C, D. So what's a parallelogram? Is pair of opposite sides are parallel. Pair of opposite sides are parallel, then it's a parallelogram. And we'll identify what are opposite sides and opposite angles. if you take opposite sides, AB and CD. If you take AD, that's with BC. What are opposite angles? Opposite angles are A with C, A and C, and B and D. And if you take diagonals, what are diagonals? Diagonals AC and BD. So you need to know in parallelograms what are opposite sides, opposite angles, and what are diagonals. Now we'll look at theorem 1 in parallelogram lesson. Here there are altogether 6 theorems. In chapter 16 and 17, altogether 6 theorems. So I'm teaching you all theorems in this lesson. First one, in a parallelogram, opposite sides are equal, opposite angles are equal. The area of the parallelogram is bisected by each diagonal. What it means? When you take a parallelogram, how can we draw? How can we draw a parallelogram? You take certain distance in your notebook, 8 squares. You take the same thing, 8 distance, 5 squares away from the other line, and then connect. When you connect, you get a parallelogram. Opposite sides are parallel. Now it says in theorem number 1, opposite sides are equal. Opposite sides equal means this length should be equal to this length. This length should be equal to this length. That's the first theorem. Opposite angles are equal. That means this angle should be able to equal to this one. This angle is equal to this one. And the third one, it says the area of the parallelogram is bisected by each diagonal. So here, what are diagonals? You know, when you connect this line, it's a diagonal. It's bisected the area. That means this area, this triangle area is equal to this one. If you take other diagonal also, it happens to the same thing. So this triangle area should be equal to the other triangle area. Now we'll try to prove this. So all these parts we'll try to prove. Okay, we'll take a general parallelogram ABCD. If it's a parallelogram, what do you know about that? I can write parallelogram is like this. So ABCD is a parallelogram. That means opposite sides are parallel. I know this line is parallel to this one, this line parallel to this one. So I can write AB parallel to CD and BC parallel to AD. That's given data. Now we need to prove that opposite sides are equal means AB is equal to CD, AD equals to BC. Those are opposite sides. Opposite angles are equal means we need to prove that A angle is equal to C angle and B angle is equal to D angle. And the third one, the area of the parallelogram is bisected by each diagonal means if you construct a line BD, you have to show that ABD triangle area is equal to BCD triangle. That's what we need to prove. So these are the things that we need to prove. Now we did a construction. Connect BD line. Now we'll start to prove that. Now we'll take these two triangles. I want to check ABD triangle and BCD triangle. What I can say about these two triangles? I can say this angle is equal to this angle. Why? What's the reason? Alternate angles are equal. These two are parallel, so alternate angles are equal. I can write ADB angle is same as DBC angle. I'll put X for that, it's easy to figure out, and this is X. And also same way, if you take other way around, this way, these two lines are parallel, so this angle is equal to this one. I'll put Y. I can write ABD angle is equal to BDC angle. That's Y. And also we can see BD is common. What's the reason for this one? Alternate angles. Now what can we say about these two triangles? Two angles and one length. So these two are congruent. ABD triangle is congruent to BCD triangle. What's the situation? Angle, side. So these two are congruent means the corresponding elements are also equal. So what are the corresponding elements? AB is the angle, the line opposite to X. What's the line opposite to this X? That's CD. So AB, therefore AB is equal to CD. And when you take the angle opposite to Y, that's AD is equal to BC. What's the reason? Corresponding elements. Corresponding elements are equal. Now we proved the first part. Corresponding elements are equal. Again, when you think about angles, this angle then corresponding to this BD line, this angle should be equal to this angle. So we can show that A angle is equal to C angle. That's also corresponding element. What about the other one? If you take B angle, what is B angle? According to this one, x plus y. Here also x plus y. So again we can write B angle is equal to D angle. That's also not corresponding elements because this is not the angle inside these two triangles. This is a separate one. So the reason is the sum is x plus y. So we found out opposite sides are equal as well as opposite angles are equal. Now the last part we need to show that the area of the parallelogram is bisected by each diagonal. Now when you take BD diagonal, what can you say about these two triangles? We found out these two triangles are congruent. Congruent means you can keep one triangle on top of the other. That means equal area. So straight away I can write, because these two are congruent, ABD triangle area is equal to BCD triangle area. Two areas are equal means the area is bisected, equally divide into two. So therefore I can write the last part of this, the area of the parallelogram bisected by each diagonal. Is bisected by which diagonal in this one? We consider BD diagonal, by BD diagonal. Similarly, if you take the other diagonal AC, you can show the same thing. So I can write similarly, area of the parallelogram is bisected by AC diagonal as well when you consider the other one. So what's the first theorem says? When you take a parallelogram, opposite sides are equal, opposite angles are equal, and the area of the parallelogram is bisected by each diagonal. Now we look at theorem number 2. It says in a parallelogram, the diagonals bisect each other. What it means? When you take a parallelogram, diagonals means this one and this one, bisect means equally divided into two. So that means this length should be equal to this one, this length should be equal to this one. So that's the theorem number 2. We'll try to prove this. We'll take a general parallelogram ABCD. These two opposite lengths are parallel. This is also parallel. So what you know about this? We know ABCD is a parallelogram. And we need to do a construction because we need diagonals. So we'll connect BD line and BC line and put O as the intersecting point. Construction, connect BD and AC lines. The intersecting point is O. We'll take the intersecting point as O. Now we need to prove AO length is equal to OC as well as OD length is equal to OB, because when it's bisecting, that means these lengths are equal. So that's what we need to prove. Now we'll try to prove this. We'll consider these two triangles, AOB triangle and COD triangle. When I take these two, what can I say about these two? AB, CD. Lines are parallel. This angle is equal to this one. I can take that one as X. This is X. This is also X. And what else? I can take this one as Y. So that's equal to this angle because these two lines are parallel. Alternate angles are equal. And also from the first theorem, we know that in a parallelogram, opposite sides are equal. So opposite sides are equal means this length is equal to this length. I can write from these two triangles, OAB angle is equal to DCO angle, as well as, that's Y, as well as OBA angle is equal to ODC angle, that's X. And also I can write AB length is equal to CD length. Why? Opposite sides are equal in a parallelogram. These two alternate angles. Now, what can we say about these two triangles? These two triangles are congruent. I can say AOB triangle is congruent to COD triangle. What's the situation? Angle, angle, side. So if these two are congruent, corresponding elements are equal. So therefore, corresponding elements are equal. So what are corresponding elements? If you take the length opposite to X, that's OA. OA is equal to, opposite to X is OC. Again, if you take Y as the angle opposite to Y, that's OB, that's equal to opposite to I angle, that's OD. So we can straight away write down corresponding elements. OA is equal to OC and OG is equal to OB. So if these are equal means, what's the second theorem says? Second theorem, in a parallelogram, the diagonal bisect each other. So we prove that these are equal. We can write therefore diagonals bisect each other. So that's the second theorem. Now we'll look at those properties of parallelogram. We did two theorems. What's the first theorem? Opposite sides are equal, opposite angles are equal. The area of a parallelogram bisect with the diagonals. And the second theorem we says diagonals of a parallelogram bisect each other. Now when you take all these, we can say when you take a parallelogram, opposite sides are equal. That means this length is equal to this length. And opposite angles, this angle is equal to this angle. This one is equal to this one. Opposite angles are equal. And the area of the parallelogram is bisected by each diagonal. Bisecting means when you draw the diagonals, this area is equal to this one, and other way, if you take this diagonal, this area is equal to this one. So those are the properties of a parallelogram. And also in theorem number 2, we discussed about diagonals. When you take two diagonals like this, those two diagonals bisect each other. That means this length is equal to this one, this length is equal to this one. So according to theorem 1 and 2, those are the properties of a parallelogram. Now we'll look at theorem number 3. Now converse of all the theorems we did before. When you take theorem number 1, opposite sides are equal. Theorem number 2, we did opposite angles are equal. And when you take the converse theorem says if the opposite sides are equal of a quadrilateral, then it is a parallelogram. So opposite of this. So we call that's the converse theorem. So we'll try to prove the converse theorem of this one. So we'll take a quadrilateral now. Any quadrilateral. I'll take any quadrilateral like this. ABCD. So what you know about this? We know that's a quadrilateral. And what you need to prove? You need to prove this is a parallelogram. That means What's the definition of parallelogram? Opposite sides are parallel. So you need to show that AB is parallel to CD as well as AD parallel to BC. Now we'll draw a line here. We'll do a construction. We can draw BD line. Now we'll take the angles. We know in this is a quadrilateral, opposite sides are equal. So AB is equal to CD. We can write under data, we know that AB is equal to CD. As well as when you take the other side, AD is equal to BC. And this is a common line. Now we'll try to prove this. We'll take ABD triangle and BCD triangle. What can you say about these two triangles? From the data given, we know that AD is equal to BC, AB is equal to CD. That's given. And BD is common. Now what can you say about these two triangles? All three sides are equal. Corresponding sides are equal. So we can straight away write down ABD triangle is congruent to BCD triangle. What's the situation? Side, side, side. So if the two triangles are congruent, what can we say about the corresponding elements? We can say this angle opposite to this line, this angle is equal to this one. So corresponding elements, ABD angle is equal to BDC angle, as well as corresponding angles, this one. This angle opposite to this line is equal to this one. ADB angle is equal to DBC. What's this reason? Corresponding elements. Now what are these angles? Alternate angles. If alternate angles are equal, what can you say about the two lines? These lines are parallel. Because of this, we can say AB is parallel to this one, CD. Why? What's the reason? Alternate angles are equal. Therefore, AB line is parallel to CD line as well as AD line parallel to BC line. Now we found out opposite lines are parallel. Opposite, pair of opposite sides are parallel means What can you say about this? Quadrilateral. This is a parallelogram. So ABCD is a parallelogram. What's the reason? Opposite sides are parallel. Pair of opposite sides are parallel. So we proved that. Theorem number 3. The converse of theorem number 1. If opposite sides of a quadrilateral are equal, then it is a parallelogram. Now we'll look at theorem number 4. That's also converse from the theorem number 1. In theorem number 1 it says, if it's a parallelogram, opposite angles are equal. So what's the converse of that? If the opposite angles of a quadrilateral are equal, then it is a parallelogram. Now we'll try to prove this also. What you know about this? This is a quadrilateral. So I can take any quadrilateral as ABCD. And I'll write here data ABCD is a quadrilateral. And it says opposite angles are equal. So that means it's given A angle is equal to C angle, B angle is equal to D angle. I'll put this one is X. So this is also X. This is Y. This is also Y. Now we'll try to prove that. This is a quadrilateral. What can you say about angles in a quadrilateral? Add up to 360. So I can write X plus Y plus X plus Y is equal to 360. That means all angles inside the quadrilateral. Then what can I say about this is double of X and double of Y. When you simplify, take 2 out, I get this one. When you divide it by 2, X plus Y is equal to 180 degrees. When you take A and D angle, if you take A as X angle, D as Y angle, A plus D is 180. What are these two angles, A plus D? If you take these two lines, these are allied angles. Allied angles are equal to 180. That means allied angles are equal to 180 means these two lines are parallel. So I can say these are allied angles add up to 180. Therefore, I can write AB line is parallel to CD line. Then think about other way around. If I take A as X and Y as B, that's also equal to 180. These two are also allied angles. aligned angles add up to 180. That means these two lines are parallel. AD parallel to BC. Now we found out pair of opposite sides are parallel. So what's a quadrilateral? That's a parallelogram. So we can straight away write down opposite sides are parallel. So opposite sides are parallel means we can say ABCD is a parallelogram. So that's the theorem number 4. That's the converse of theorem number 1. Now we'll take theorem number 5. It says if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. That's the converse theorem of theorem number 2. Theorem number 2 says if it's a parallelogram, the diagonals bisect each other. The converse, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. We'll try to prove this also. We'll take any parallelogram, not a parallelogram, any quadrilateral ABCD. So we know ABCD is a quadrilateral. And also it says diagonals of quadrilateral bisect each other. So that means we can draw these two diagonals and say this length is equal to this length and this is given as this. So under data we can write OD is equal to OB as well as OA is equal to OC. That's given. Now what you need to prove? We need to prove that ABCD is a parallelogram. So parallelogram means we need to show that AB is parallel to CD, AD is parallel to BC. Now we'll try to prove that. We can take these two triangles, OAB triangle and OCD triangle. What can you say about these two triangles? From the given data, we know that OA is equal to OC and OB is equal to OD. That's given. What can you say about these two angles? This one is equal to this one. What are those? When you take any two straight lines intersecting, the opposite angles are equal. So I can write AOB angle is equal to COD angle. That's opposite angles. Opposite angles are equal. Now we know when you take these two triangles, two lengths and included angle equal to other triangle. So what can you say about these two triangles? OAB triangle is congruent to OCD triangle What's the reason? Side angle, or we can say side angle side, and also we know this angle is included angle. Two sides and included angle equal means these two triangles are congruent. Now, we found that these two are congruent. We can say corresponding elements are equal. So, what are the corresponding elements? Corresponding elements to this line, this angle is equal to this angle. I can write ABO angle is equal to ODC angle, and when you take this way, this angle is equal to this angle. OAB angle is equal to DCO angle. Those are corresponding elements. Now, what are those? When you take this one with this one as well as this one with this one, these are alternate angles. We found that alternate angles are equal. These are alternate angles. So, alternate angles are equal. What can you say about the two lines? The two lines are parallel. So, here this angle is equal to this angle. That means AB line is parallel to CD line, and when you take AD line parallel to BC line. Now we found opposite sides are parallel. That means this is a parallelogram. Opposite sides are parallel. Therefore, ABCD is a parallelogram. So that's theorem number 5. So what is theorem number 5? It says if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now we'll look at theorem number 6. In theorem number 6, it says in a quadrilateral, if a pair of opposite sides is equal and parallel, then the quadrilateral is a parallelogram. So, it says in any quadrilateral, one pair is equal as well as parallel. Then it's a parallelogram. We'll try to prove this. So what you know about this? We'll draw a quadrilateral first. I'll take ABCD is a quadrilateral. So what you know about this? ABCD is a quadrilateral. And also we know that one pair of opposite sides is equal. So if I take AB, it's given AB is equal to CD as well as AB is parallel to CD. That's given. Now you have to show that. This is a parallelogram. Already one side is parallel and equal. So you need to show the other pair also parallel. We need to show that AD is parallel to BC. Now we'll try to prove that. We'll take a construction. I can connect this line. So I'll draw a construction. Connect BD line. AD is parallel to BC. We need to show that. But we know these two lines are parallel. I can say that this angle is equal to this one. Why? Alternate angles are equal. And also I know this side is equal to this side. So I can show that these two triangles are congruent. We'll take ABD triangle and BCD triangle. From these two triangles, I know AB is equal to CD. Opposite sides given. Opposite sides are side equal. And also BD is common. And these two angles are equal because alternate angles. I can write ABD angle is equal to BDC angle, alternate angles. Then what can you say about these two triangles? Side, angle, side, and this is also the included angle. So included angle and two sides equal, that means ABD triangle is congruent to BCD triangle. What's the situation? Side, angle, side. Now these two are congruent, so the corresponding elements are equal. Corresponding elements are equal means I can say this angle opposite to this line is equal to this one. ADB angle is equal to DBC angle. But we know these are alternate angles. Alternate angles are equal. Alternate angles are equal means we can say the two lines are parallel. So ADB, these two angles are equal means AD is parallel to BC. AD is parallel to BC. Now we found out the other pair of opposite sides also parallel. Therefore, we can say ABCD is a parallelogram. So that's the last theorem. So last theorem, if it's a quadrilateral and if a pair of opposite sides equal and parallel, then it's a parallelogram. So we did altogether how many theorems? We did 6 theorems. Now we'll try to revise. First theorem, what it says? In a parallelogram, opposite sides are equal, opposite angles are equal, and the area of the parallelogram bisect by the diagonal. And the second theorem, what it says? First I'll sketch the diagram. In first theorem, it says opposite sides are equal and opposite angles are equal. And the other one, from the diagonal, this area is same as this one. So area, I'll put A and this is also. Areas are equal. Second theorem, it says in a parallelogram, the diagonals bisect each other. That means these lengths are equal. That's the second theorem. Third theorem is the converse of first theorem. Converse means it says opposite sides are equal in a parallelogram. If it's a quadrilateral and opposite sides are equal, then it's a parallelogram. If it's a quadrilateral with opposite sides equal, then it's a parallelogram. Fourth one is the converse of this one. For any quadrilateral, if opposite angles are equal, then it's a parallelogram. Fifth one, converse of the second theorem. Converse of the second theorem, in any quadrilateral, if the diagonals bisect each other, then it's a parallelogram. And the last one, it says, what's the last one? In a quadrilateral, one pair of opposite sides equal and parallel, then it's a parallelogram. So remember all these 6 theorems related to parallelograms to do the exercises and the examples. Now we'll take this example. You have given a parallelogram. Why? It says opposite sides are parallel. So that's a parallelogram. Find DC. DC is the opposite side to AB. Opposite sides are equal in a parallelogram. Straight away I can write this is 10 centimeters. AD is the opposite side to BC. In a parallelogram, opposite sides are equal. I can write AD as 7 centimeters. Find angle A. Angle A is the opposite to angle C Opposite angles are equal. This is 60 degrees. How can I find B? B I can find using allied angles. This is a parallelogram, so allied angles add up to 180. So I can write B plus 60 is 180. What's the reason? Allied angles. What is B? 180 minus 60 degrees. I get 120 as B angle. B angle and D angle, opposite angles, I can straight away write down. D angle is also 120. Example number 2. Find the other angles. So one angle is given 110. That's P angle. Other angles, what's R? R is 110. Opposite angles are equal. Then I can find S using allied angles. S plus P is 180. So what's the S angle? 180 minus 110. I get 70 degrees. What's the reason? Allied angles add up to 180 degrees. So the S angle is 70. If S is 70, Q is also 70 degrees. That's opposite angles. Now we found all the other angles. Now it says, if area of the parallelogram is 48 square centimeters, find the area of QRS triangle. QRS triangle is this. According to theorem number 1, the area of the parallelogram is bisected by the diagonals. So here SQ is a diagonal. So straight away we can say this is half of the area of the triangle. So I can give the answer. QRS triangle area is half of the parallelogram area. That's 48. 24 square centimeters is the area of QRS according to theorem number 1. Parallelogram area bisected by diagonals. We'll take this example. You're asked to find out the values of A, B, C, D, E. Look at carefully. It's given A, B, C, D is a parallelogram. A, B, P, Q is also a parallelogram. And if you take A, B, P, Q parallelogram, what can you say about A? A is straight away 70 degrees. What's the reason? Opposite angles are equal. So we found this is 70. Look at these two angles. These are allied angles. So we can find B using allied angles. 180 minus 70 plus 30 is 100. You get 80 degrees. What's the reason? Allied angles add up to 180 degrees. So straight away you can write C angle is the opposite angle to B. So C angle is 100 degrees, that's 70 plus 30, opposite angles. Then D and B opposite angles when you consider ABCD parallelogram. So D I can write same as B, that's 80 degrees, that's also opposite angles. And what about E? E is the allied angle with this 70-degree angle. I can write 180 minus 70, that's 110, because of allied angles add up to 180. So we found all 5 angles. Let's take exercise 16.1 in your textbook. It says, according to the information in the parallelogram PQRS, find the length of the side PQ. This is a parallelogram. Opposite sides are parallel. So what can you say about PQ? PQ is same as 8 centimeters because opposite side SR is equal to PQ. Second part, find the magnitude of each of the angles QPS. QPS, this angle. So QPS angle is 180 minus 130 because those are allied angles. 180 minus 130, it's 50 degrees. Then we want PQR angle. PQR angle is the opposite angle to S. That's straight away 130 degrees, opposite angle. Then last one, QRS angle. QRS angle is this one. This is same as P angle. So what's P angle? That's 50 degrees. So that's equal because of opposite angles. Question number 2. Based on the data in the figure, find the magnitude of BCD. BCD is this one. So what's the magnitude? BCD is 180 minus 78 because allied angles add up to 180. So when you subtract, what you get? 102 degrees. Second one, if the area of the parallelogram ABCD is 24, what's the area of the triangle BCD? We know that the area is bisected by the diagonals. So BD is a diagonal. So straight away we can write BCD area is equal to half of the area of the parallelogram, that's 12 square centimeters. Third one, what is the area of the triangle ACD? ACD is also the triangle with the other diagonal. So what's the area? ACD triangle also same as before because the area of a parallelogram bisect each other with the diagonals. Question number 3. Based on the information on the figure, find the length of DC. Here these two lines are parallel, and here this is a parallelogram and this is also a parallelogram. ABCD as well as ABEF both are parallelogram. Find the length of DC. We know that FE is 5, so this is 5 centimeter. When you consider this parallelogram, this is also 5 centimeter. Opposite sides are equal. So what's the answer for the first one? CD length is same as 5 centimeters. Second one, find the magnitude of ABE. ABE is this angle. That's opposite to 45. So what can you say about ABE angle is 45 because of opposite angles. Third one, find the magnitude of ADC. ADC is this angle. We know that this is 45. So what's the total angle here? 75 plus 45. That's equal to D angle. ADC angle is 45 plus 75. 120 degrees. Last part, find the magnitude of BCD. BCD is this angle. This angle is the allied angle to D angle. So allied angle means add up to 180. I can straight away write down 180 minus 120. We get 60 degrees. The reason is allied angles. Question number 4. Based on the information in the figure, find the length of PS. Here, PQRS is a parallelogram. XYZ are also a parallelogram. PS is here. This length is given equal to this length, but we know this is also equal to this one. And here this length is equal to this one. What can you say about XY and SP? Both are equal. I can straight away write down PS is also 3 centimeters. Second one, the magnitude of QPS. QPS. Where's the angle? QPS is this angle. I can write this is 60 because opposite angles are equal in this parallelogram. This is 60, this is also 60. Opposite angles are equal. If this is 60, this is also 60 degrees. Opposite angles are equal. Third one, PQR. PQR is this angle. So that's the allied angle to 60 degrees. So I can write 180 minus 60 degrees is PQR angle. So 120 degrees for Q angle. Question number 5. Find the magnitude of each of the angles denoted by ABCD based on the information in the figure. We can see MLKN is a parallelogram. Opposite sides are parallel. And this is 40 given. alternate angles are equal, this should be 40. I can write B angle is 40 degrees because alternate angles are equal. C and this angle also alternate angles. So C angle is equal to 57. Same reason, alternate angles are equal. I can write this is 57. Here this one, A is 35. That's also alternate angles are equal. So this is 35. And we found ABC. What's D value? D value is this one. How can we find out that angle? We can use allied angles property. I can write D angle is equal to 180 minus all the other angles. Either this way or this way. I'll take this one. 57, 40 and 35. Because this plus this plus this plus this all 180. Now we'll simplify this. 180 minus 1 remaining here 6. 6 plus 4 10, 13, 132. 180 minus 32 is 48 degrees. So D angle is 48 degrees. So we found all A, B, C, D angles. Question number 6. Based on the information in the figure, write down two sides which are equal in length to DC. DC is this one. What's given here? This is a parallelogram. DCFE is a parallelogram. And also this is also a parallelogram. Which length is given? Not given, but we know DC is equal to EF. Opposite sides of a parallelogram is equal. Then what's the other one? They are asking two lengths, two sides which are equal. But if you take this parallelogram, this is equal to this one, AB. So that's also equal to DC. Second part, find the magnitude of the angles denoted by XYZ. We'll take X first. What can you say? If this is 50, I can write this one as 50. Opposite angles are equal. And also, if this is 60, this is 60. What else we can mark? And we know this is equal to 90 degrees. So, first thing we can do, we can find Z letter. Z is 90 minus 60 degrees, that's 30. We found this is 30 degrees. And if this is 60, what's X value? 180 minus 60, that's allied angles. That's 120 degrees. So we found this is 120. And this one, if this is 50, what is this angle? This angle is 180 minus 50. What's this one? AEF angle is 180 minus 50. That's 130. Now, when you look at this point, we can find out the Y angle. Y angle is Y angle plus X plus 130 is 360 angle at a point. So Y equals 360 minus 130 and also minus the X value. X value is 120. So 360 minus, when you add these two, you get 250. When you subtract, you get 110 as the Y value. So we found X is 120, Y is 110 and Z is 30 degrees. Question number 7. The figure depicts two parallelograms ABCD and ADFE. According to the information given in the figure, find the length of BC. BC is this one. Look at this diagram. This is a parallelogram. So AD and BC should be equal. And AD is given 5 centimeters, so BC also 5 centimeters. Find the magnitude of each of the angles CFD. Where is CFD? This angle. Here, all these three sides equal means what are these angles? All these are 60 degrees. Why? Equilateral triangle. Equilateral triangle angles are 60 degrees. Here also equilateral triangle 60, 60, 60. So straight away I can write this one as 60 degrees. What's ADC angle? ADC angle is this one. This one I can find either using alternate angles here, because these two lines are parallel. Straight away I can write that's also 60 degrees. Alternate angles are equal. This and this. Then the last one, ECD. Whereas ECD is this angle. So this is a straight angle. I can write this one as 180 minus 60 degrees. 120. What's the reason? That's a straight angle. Look at example number 1. The points P and Q are marked on the diagonal BD of the parallelogram ABCD such that BP and DQ both are equal. Already marked there. Prove that ADQ triangle is congruent to BPC triangle. So we'll try to prove that. Let's take ADQ triangle and BPC triangle. ADQ, this one and this triangle. We know that DQ is equal to BP. That's given. And also, when you take these two parallel lines, this is equal to this angle. Alternate angles. ADQ angle is equal to CBP angle. That's alternate angles. Now also we know ABCD is a parallelogram. Then what can you say about the opposite sides? I can say AD is equal to BC. Opposite sides of a parallelogram. Then we can say side angle side. This is the included angle. I can write this is also included angle. So therefore, ADQ triangle is congruent to BPC triangle. What's the situation? Side angle side. That's the first part. Then the second part, it says AQ parallel to PC. So to show that AQ parallel to PC, we need to show that this angle is equal to this angle. Then if alternate angles are equal, we can say AQ is parallel to PC. How can we do that? We know that these two triangles are congruent. Then corresponding elements are equal. So what are the corresponding elements we need? We can say DQA angle is equal to this one is equal to this one. BPC angle. Then I want to subtract from 180 both sides. 180 minus DQA. 180 minus BPC. What's that? 180 minus this angle is this one, AQP. That's equal to AQP angle. This is AQP angle. 180 minus BPC. BPC angle is QPC. We found this angle is equal to this one. So those are alternate angles. So these are alternate angles, and alternate angles are equal. If alternate angles are equal, I can say that AQ is parallel to PC. AQ is parallel to PC. So that's the second part. Example 2 in your textbook. According to the information given in the diagram, prove that O is the midpoint of XY. So O is the midpoint means we have to show that OX is equal to OY. We need to prove that this is equal. Then O is the midpoint of XY. So we know these all are parallelograms. All sides are parallel. So we'll try to take these two triangles. If you take this triangle and this triangle, what can you say about those two? We'll take AXO triangle and OCO y triangle. This angle is equal to this one. XOA angle is equal to COY angle. What are those? Opposite angles. Opposite angles are equal. And also, these two lines are parallel. This angle is equal to this angle. This one is equal to this one. And also, what you know? This length is equal to this one. That's the diagonal. Diagonals bisect each other in a parallelogram. So this is a parallelogram. This length should be equal to this one. So I can write AO is equal to OC. Diagonals bisect. We have angle, side and another angle. What's the other angle? We can write either this or this. I'll write this angle. AXO angle is equal to OYC angle. That's alternate angles. So these two are congruent. AXO triangle is congruent to OCY triangle. What's the situation? Angle, angle, side. So if the two triangles are congruent, we can say corresponding elements are equal. Corresponding elements means OX is equal to OY. I'll write corresponding elements. Corresponding elements are equal. That means if OX is equal to OY, that means I can write O is the midpoint of XY. Exercise 16.2 in your textbook. In the parallelogram ABCD, the midpoint of BC is E. That means this length is given equal to this one. DE and AB produced meet at Q. Prove that AB is equal to BQ. So we need to prove AB is equal to BQ. We'll take these two triangles first. We'll try CDE triangle and BEQ triangle. BEQ triangle. When you take these two triangles, we know that CE is equal to BE. That's given as midpoint. And also, this angle is equal to this one. DEC angle is equal to BEQ angle. Those are opposite angles. And what else we know? This is a parallelogram. So this length is equal to this length. And also we know this is parallel. These two lines are parallel. This angle is equal to this angle. Alternate angles. CDE angle is equal to EQB angle. That's alternate angles. We have two angles and one side. Two angles and one side means these two are congruent. These two triangles are congruent. What's the situation? Two angles and one side. If the two triangles are congruent, the corresponding elements also equal. So corresponding elements, I can write CD. Opposite to this angle is same as BQ. Corresponding elements. Now what can we say? We found out this length is equal to this length now. But we know CD. CD length is equal to AB as well as CD is equal to BQ. From these two I can write BQ should be equal to AB. BQ is same as AB. So this is also equal. So what can you say about the B point? B is the midpoint of AQ. So AB is equal to BQ. Question number 2. In the parallelogram ABCD, in the figure, the perpendiculars drawn from B and D to AC are BL and DM. Respectively, show that BL, this length is equal to this one. To do that, we have to consider these two triangles. AMD triangle and BLC triangle. First thing we can write DMA triangle is equal to BLC angle, that's given as 90 degrees. And this is a parallelogram. ABCD is a parallelogram. AD length is equal to BC. Opposite sides are equal. This one is equal to this one. And what else we know? We know that these two lines are parallel. This angle is equal to this angle. Those are alternate angles. So DAM angle is equal to BCL angle. Those are alternate angles. So two angles one side equal, that means AMD triangle is congruent to BLC triangle. What's the situation? Angle, angle, side. If these two are congruent, what can you say about corresponding elements? Corresponding elements are equal. So corresponding elements opposite to this angle is BL is equal to dm. That's corresponding elements of the two congruent triangles. Question number 3. The figure illustrates two parallelograms PQRS and QYSX. Prove that PX equals RY. PX equals RY. So we'll first connect SQ and C, and then we'll write this as O. We know SYQX and SRQP both are parallelograms. According to the theorem, the diagonals bisect each other. So that means if you take SYQX parallelogram, we can say OY is equal to OX. Diagonals bisect each other. When you take the big parallelogram SRQP parallelogram, what can you say about that one? OP is equal to OR. I'll write OR here, OP here. That's also diagonal. Bisect. Now I want to subtract these two. We'll take 1, 2 here. 1 minus 2. OR minus OY. OP minus OX. What you get? OR minus OY, I'm getting YR. If I subtract OP minus OX, I am getting PX. So these two lengths are equal. Second part, the area of PSXQ. This area is equal to this one. Now we know according to the theorem, the area of the parallelogram bisects with the diagonal. So SQ is a diagonal. So we can write this area is same as this area, as well as when you take the other parallelogram, SYQ area is same as this one. First I'll take the bigger one. SRQ triangle is equal to SQP triangle as well as SYQ triangle is equal to SQX triangle. Both these because of theorem number 1. Area of parallelogram bisect by diagonals. Now I want to subtract. I'll take this one as 1, this one as 2. 1 minus 2. Bigger area minus smaller one. SRQ triangle area minus SYQ triangle area is equal to SQP triangle area minus SQX triangle area. When you subtract, what you get? SRQ triangle area minus SYQ. I'm getting the smaller area, this part. That's what we need. We call it S. We can start with SRQX. SRQY. SRQY. So this is SRQY area. When you subtract the other way round, you get this area. So this area is PSXQ. So those two are equal. Question number 4. PQRS in the figure is a parallelogram. The points X and Y lie on PR such that PX, XY, YR all are equal. It's given. Prove that QX is this one, is equal to SY. We'll take again two triangles, SRY triangle and PXQ triangle. When you take those two triangles, we know PX is equal to YR. That's given. And also, this angle is equal to this angle. Alternate angles are equal because PQRS is a parallelogram. XPQ angle is equal to SRP angle because it's alternate angles. And also this is a parallelogram. Opposite sides are equal according to theorem. So opposite sides are equal means PQ is equal to SR. Opposite sides of a parallelogram. What can you say about the triangle? Two lengths and included angle equal. That means SRY triangle is congruent to PXQ triangle. What's the situation? Side, angle, side. Side, angle, side. And you need to show that this is also the included angle. Then side, angle, side. Now we found out these two triangles are congruent. The corresponding elements are equal. So corresponding element opposite to this angle is QX and opposite to the other angle, that's SY. So SY is equal to QX. That's the first part. Second one, it says QX parallel to SY. To show that these two are parallel, I need to show that this angle is equal to this angle. If alternate angles are equal, then I can say QX and SY are parallel. From the congruent triangles, I can write PXQ angle is equal to SYR angle. SYR angle. So that means this angle is equal to this one. Those are corresponding elements. I want to subtract from 180 these two angles. So what I am getting? I am getting 180 minus px cube. 180 minus px cube means I am getting r yx, or I can write qxy angle. So this is qxy. What about this one? 180 minus SYR is SYP angle. Now we found out these two angles are equal. Alternate angles are equal means the two lines are parallel. I can write QX is parallel to SY. Question number 5. The figure illustrates a parallelogram ABCD. ABCD is a parallelogram. Straight away I can write down the parallel lines. The points X and Y lie on the sides AD and BC respectively, such that DX is equal to BY. Prove that ABY triangle is congruent to DCX. ABY. This triangle is congruent to DXC triangle. So we'll take those two, ABY triangle and DCX triangle. We know that YB or BY is equal to DX. That's given in the question. And also we know that opposite angles are equal in a parallelogram. This angle is equal to this angle. So I can write CDX angle is equal to ABY angle. That's opposite angles are equal. We have two angles equal, and what else we know? ABCD is a parallelogram. Opposite sides are equal. I can write CD is equal to AB. Opposite sides are equal. Now, two lengths and one angle, and the angle is the included angle. This is also included angle. So we can write ABY triangle is congruent to DCX triangle. What's the situation? Side, angle, side. And the second part, it says show that AY and XC parallel. Now we found out the two triangles are congruent. So the corresponding elements are equal. I can write CX is equal to AY. That's corresponding elements. So this length is equal to this length. And also I can write down this length is equal to this length because that's a parallelogram. AD is equal to BC, and I can subtract this equal distance from that. These two are equal. I can subtract YB from this side. AD, I'll subtract DX from this side. That's same as BY. DX from this side, DX is same as BY. BY from this side. What's the answer? AD minus DX, I am getting AX. So this is AX. BC minus BY, I am getting CY. Now I know these two lines are parallel because it's a parallelogram, and these two sides are equal as well as parallel. What can I say about this diagram? AX CY is a parallelogram because AX is equal to, now I found, I'll use another color. This length is equal to this length, and it's also parallel. So what can you say about that? This is also equal. So this should be a parallelogram. So if this is a parallelogram, CX should be parallel to AY. So we can say CX AY is a parallelogram. Then straight away I can write CX should be parallel to AY. Question number 6. The figure depicts two parallelograms named ABCD and APCQ. Prove that the lines AC, BD and PQ are concurrent. What is concurrent means? Passing through the same point. So AP AC, this line, BD, this line, and PQ. PQ all passing through the same point. You have to show that. How can we do? We know when you take A, B, C, D parallelogram, AC and BD are diagonals. AC and BD diagonals intersect at O. And also when you take AQCP parallelogram, what can you say? AC is the diagonal of that parallelogram. AC and PQ diagonals intersect at at O, because those two are diagonals of that parallelogram. So what can you say about these two? All lines are passing through point O. So therefore, AC, BD and PQ all intersect at O. That means AC, BD and PQ are AC, BD, PQ are concurrent. That means passing through the same point. Question number 7. In the parallelogram PQRS, the bisectors of this meet the point X on the side PQ. We need to draw the diagram. In the parallelogram PQRS, the bisectors of PSR, the bisector, I'll take bisector means angle divided into equal parts. Bisector and QRS bisector meet at point X. So this is point X on side PQ. So this is also bisector means this is B, this is also B. And also it's a parallelogram. This length is equal to this one. So I'll write this length is equal to this one, this length is equal to this length. Prove that. First, draw the figure with above information included in it. Second one, prove that PX is equal to PS. PX is equal to PS. These two sides are equal. But we know in this diagram, this angle and this angle equal. Why? Alternate angles. I can write PXS angle is equal to RS X angle, and also this is because of alternate angles. And also we see now these two also equal, A and A. That's also equal to, this is also equal to this angle PSX. PSX is equal to PXS angle. So this angle is equal to this one. In this triangle, two angles are equal. What can you say about the alternate sides? The opposite sides of these interior angles also equal. So when you look at PXS triangle, I can say PX length is equal to PS. This is an isosceles triangle. Isosceles triangle. So first part we proved. Now we need to show this one. Prove that X is the midpoint of PQ. No? So that means we have to show that PX is equal to XQ. But we know that from this parallelogram, this angle is also equal to this angle, and this is also an isosceles triangle. So similarly, I can show that XRQ is an isosceles triangle. So if this is isosceles, that means XQ is equal to QR. But we know QR is same as SP. SP we found using the first part. SP is same as PX. That's from part 2. So what can you say about all these lengths? This one is equal to this length. This is also equal to this one. This is this one. So these two lengths are equal. So PX is equal to XQ. We can say straight away X is the midpoint of PQ line. Now fourth part, prove that PQ is equal to double of PS. So this is also from the previous part. We can straight away write down PQ. In PQ, X is the midpoint now. So we can write PX plus XQ. Instead of XQ, I can write PX so you get 2 PX is PQ. But we found PX is equal to PS. I can substitute instead of PX, PS. So what's PQ? I can write PQ is 2 times PS. In this chapter, we covered all theorems related to parallelograms. We did 6 theorems. So in next chapter, we will apply some of the theorems in exercises and examples.